Hi there, this is not Joe Pieczynski, this is David Dyer, and today we're going to do a little tutorial about what I know about freewheel hobbing. This is just a hobbyist approach, and there's nothing professional about it. There's no Joe Pieczynski about it. There's just me, who has had 2 weeks of informal training by a friend of mine about 40 years ago. And so what you see here is just an amateur approach to freewheel hobbing. Nevertheless, here we go. Here is my first setup and my first try at making a gear with free hobbing. Here's how it looked. It's completely freewheeling here. That's important. I'm going to jam the hob in tightly to the blank. Notice how it can't turn anymore. I'm going to try turning on the mill with the hob jammed into it. Well, there's a teaching moment for you, isn't it? You'll notice in the rest of the video that I changed the hob to the other side of the blank and also put a keyway in the holder. Let's try this. There we go. We have success here, people. As you can see, I was pretty excited about this when it first started working, but it didn't work out as well as I hoped. And here I'm putting a witness mark on the blank so you can see the rotation as it goes around. Now notice the damage on the leading edge of the gear here, where the mill slipped as it was starting and sort of ate off the leading edge. You'll notice that we are getting some semblance of a gear here, despite all the problems, setbacks, and inexperience. This is just a quick look at the tooth form that was achieved by this first try. Another question which people have had is, will the gears mesh? Will they turn together? Well, the answer is yes, they will. Now, they may not be a perfect tooth form, but they're meshing and they're mating and they're working together. As you can see, however, not everything was coming up roses. We encountered several problems, including this problem of damaging the gear when starting. So to try to correct that problem, I developed a technique of gashing manually by hand using the drawbar of the mill and a ratchet. This is my first try using a very long ratchet, which is actually a torque wrench. This did not work out well because it wasn't high enough and it hit the motor as I spun it around. The problem was that it was way too long. It was way too much torque, way more than I needed for the job, so I ended up using a much shorter ratchet. Here I'm getting ready to gash, touching off the hob on the gear blank and then moving in about 10 to 15 thousandths to begin gashing. And I'm going to enter in about 10 or 15 thousandths and start turning it by hand to gash some little gouges into the gear blank so I can start turning it with the mill without damaging it. It's going to take some experimentation here, depending upon what kind of material you are using, as to how far you can go in to gash. I went around about 3 times, going at about 10 or 15 thousandths a time to get a good grip, a good gouge for the teeth of the hob to grip into the gear blank and get it turning smoothly once I turn on the mill. A word of caution here, when you're gashing by hand, do not let the hob turn backwards, or you will lose your orientation and start a new set, possibly start a new set of gouges into the blank. Don't ask me how I know that. This gashing is a very important step, and each person is going to have to learn through trial and error how deep to gash for each different kinds of material. Also, according to Law's book on gears, you should cut the full depth of the gear at one time and not sort of go back and forth many times. This may be true. I couldn't tell you from experience for sure, but it seems like to me that you can, once you gash the blank and get the blank moving with the hob, you can move in to full depth of cut and then work the x-axis back and forth until you get the gear form all the way across the blank. One problem which I encountered was what I thought was a lack of rigidity. So I went and made a whole new fixture. Instead of clamping this aluminum bar in the vise directly, I made a new fixture for it. This is a new fixture which I made. I don't know if you remember the old fixture, which just had a piece of nylon on it. This is the bottom of it to clamp in the vise so it keeps it straight. I replaced just a slip fit with 2 pillow block bearings, and then I put a keyway in. So what happens is you take your gear blank, you slip it over, and I put on a spacer, and this is just another spacer nut here, and then I fasten it on like that. Okay, that's pretty simple. And this whole piece turns freely. Although this does have a lot more resistance than the previous setup because these pillow block bearings are kind of sticky. They're brand new and they don't turn easily, whereas the previous setup that I had turned quickly, easily in my hand. But I wanted more rigidity for this setup, and so this is what I did. Try to provide 2 bearings so it was just not held in a vise. And also I added the keyway so that the gear blank would not slip on the shaft if you applied cutting pressure. Okay, here's another part of this setup which I did. You notice how the point of this axle is conical. I made that so that I could snug this angle plate here and keep support. This side is well supported in the vise, but I wanted to cut down any possible chatter, and so I pressed this bearing into a pocket in this steel plate here and put it on an angle plate so I can lock her down and keep, so this will resist any downward or sideways pressure that there might be. Also, you can see I modified my spindle and put a keyway in there. Now, here are some previous gears. Here we have a successful gear. It's 2-inch diameter aluminum stock, and I used a 24 DP hob. Amazingly, it gave me 48 teeth. This is without any gashing, previous gashing ahead of time. Just starting the gear, as you will see in the video here, by putting a little pressure, a few thousandths pressure, on the gear blank with the hob, and then starting up the mill, which has, unfortunately, not a very low speed. Just as an aside here, I think people would be much more successful with the VDF on their mill, so they could maybe even gash just using the motor of the mill at a very slow speed, and then slowly crank up the speed to the desired velocity until they get the results they want. A VDF would have been great in my opinion. Now, as you can see here, hopefully, these teeth are fairly straight across. I'll move the light here, maybe you can see better. These teeth move straight across the gear blank. This is without any gashing whatsoever to try to control the direction of the teeth. However, because of pressure from the other people in the group and wanting to know, saying you have to tilt the head, you have to tilt the head. Here is another gear made with stainless steel. Now let's talk spindle tilt. As you will see, if you hear some chomping in the background, it's because I'm having to eat a little crow. I decided to tilt the spindle and see what happened, and so I tilted it in 2 degrees counterclockwise. And what this produced was a gear in which the teeth ran at kind of a helical angle. I'll show a picture of it here. Now, as it turns out, I believe I tilted the head the wrong way. It's supposed to be tilted clockwise and not counterclockwise. One of the things I became concerned about was the gear form. When I was using the 24DP hob, they were really tiny gears and it was hard to see the gear form. But I became concerned that they weren't really involute forms. And so I decided to try a larger hob, with larger teeth that is, and so I set the mill at 0 degrees tilt and gave it a try. Okay, gentlemen, here are the results of using no tilt on the head. 0 degree tilt. Can you see the U-shaped tooth form? Now I tilted this head 1.5 degrees clockwise, and it gives a much better tooth form. I don't know if you can see that. Somewhat correct tooth form. Maybe not perfect. Maybe I need to tilt the head just a little more. Also, these teeth seem to go straight across the head, whereas when I tilted the head to the left, counterclockwise, the teeth went at an angle. But when I tilted the head clockwise, I got straight teeth right across the face. So I'm going to have to eat my words that I said to everyone about offsetting the head, causing the teeth to be at an angle. They are, if you offset it counterclockwise. Offset the head 1.5 degrees clockwise and produce this gear fairly easily. It may be that I need to tilt the head just a little more to get a more involute form. And we got 36 teeth. This is a 2-inch gear blank. 2 inches the outside diameter, not the correct diameter. And I counted 36 teeth here. I think this is infinitely doable to produce a set of gears that would run together, at least decently, using this method. I'm calling this a victory. This is kind of sad with the U-shaped tooth form, but this over here is much better, and I think it could be improved experimenting with the tilt of the head. Anyway, I have no need for gears at the moment, so I'm not going to pursue this any further, but I think this video will give people enough information so that they can dive in for themselves and begin making gears. Here is a very hayseed method I'm using to put this blank for facing off in the lathe. This is just a reamer I use to ream it to size, which is a 1/2-inch reamer. Just using that as a guide to hold it while I grab it with the teeth so I can face it off. I don't know if this is legitimate or kosher or not, but it works okay just to face off one side. I hope you have a bunch of fun making gears with this new method.